Alrighty, in this lesson we are working on story problems and solving story problems, real world problems, using some of our strategies that we've learned with division and with multiplication and addition and those kinds of things. So just solving real world problems. So here we have our story problem. We have Mr. Frere, who distributed $126 equally among his 4 children. Okay, how much money did each child receive? Okay, so you can see I highlighted the important details here, and then we're going to start solving this problem. So I have $126, and he's going to share that or distribute that equally. So equally means we're going to end up dividing this by 4, okay? If we were asked to show this with a model, it could look like this. This could be our 120. Oh, and I put 4 up here and it's 126. Let me erase that really quickly. Shoop, shoop, shoop. 126. This could be our 126, right? And we want to make it into 4 equal pieces. And I know those don't look perfectly equal, but this would be a good way to model it, is that we're trying to find out what one of these pieces, each one of these pieces is, and how many units that might be. Remembering it's money, so money is always good to go out into decimal form, and that's fairly simple to do here. I'm going to do the traditional algorithm, but I want you to understand that we could show it with this model here as well. So I'm going to erase this portion of it to get it out of our way, and then I will come back to that portion of it. So we're going to look at it, and then we're going to look and think, okay, does 4 go into 1? Nope, sure enough, does not. That would be too little. 1 is too little for 4 to go into it. But does 4 go into 12? Sure it does. I can count by 4s. 4, 8, 12. So it goes 3 times. So I'm going to put a 3 up here. 3 times 4 is 12. And I'm going to subtract. I get a 0, right? I'm going to bring down my 6. Now 4 doesn't go evenly into 6, but 4 does go into 6. It goes 1 time. I'm going to take away 4. I'm going to subtract. I get 2. Okay, I put a decimal in, so I'm going to bring my decimal straight up. I'm going to add a 0 here because, again, it's money. So I can do that, no problem, right? I'm going to bring my 0 down, and now I have 20. And if I know my basic facts, 4 goes into 20, right? 4, 8, 12, 16, 20. It goes in 5 times. So 5, I get 20, and I get a 0 here. So now if we go back and we think about our model from before, if we had 126 and we divided it up into our fourths, what we would learn is that each child got $31.50. So each one of these pieces was worth $31.50. Okay? And so now we have solved that problem. We would say each child got $31.50. Okay, so let's go ahead and go on to our next story problem and take a look at it. We have Brandon here, and Brandon is going to make a trail mix with cashews. He has 6 83 pounds of cashews, with 3 57 pounds of peanuts. He fills up 6 bags, and they're all the same size, and he has left 3,500 pounds of nuts. So what we're going to do is we're going to start out, and this is a multi-step problem, right? He is mixing them. Mixing them is like combining them. So he's combining 6 83 with 3 57. So we're just going to start out, we're going to add those up, okay? So 7 plus 3 is 10, carry our 1. 8 plus 1 is 9, plus 5 is 14, carry our 1. Bring our decimals straight down, don't forget to do that. 6 plus 3 is 9, plus 1 more is 10. Okay, so we have this part. This is how much he had in all, right? And he's going to divide that up into 6 bags, but there's left over, right? So there's this little part that's left over. One, two, three, 4, 5, 6. And then here's our little chunk that's left over. This is 35 hundredths. Okay, and we have 10 and 40 tenths. Okay, so what I want to do first is I want to just take this off. I want to like get rid of it. Like we know that's going to be left over, so let's just remove that to start out with. So we're going to do some subtraction and we're going to take away 35 hundredths. Line up our decimals, okay? We're going to have to do some borrowing. This is going to be a 3, this is going to be a 10. We get a 5 here. 10 minus 5 is 5. 3 minus 3 is 0. Okay, so now we have our number. That's just how many nuts there were in all, taking away our leftovers. Now we have to actually do the division on this. So I'm going to erase this portion of it so that I can write over here on this other side. And we're going to actually divide this out. You guys know by now I like traditional algorithm. You are welcome to use the place value algorithm or any other modeling that you prefer. I'm going to do traditional. Okay, so I know 6 will not go into 1. It's too big. You can't take any 6s into this one, but 6 goes into 10, right? If I think about the number 10, there's 1 6 within that, so I'm going to put a 1 down. 1 times 6 is 6. I'm going to subtract. 10 minus 6 is 4. I'm going to make sure I bring up my decimal because it just goes straight up. I'm going to carry down my 0. Okay, 6 into 40. 6 goes evenly into 40. Let's see, 6, 12, 18, 24, 30, 36. Oh, it doesn't go evenly in. Bummer. So 6 times 6 is 36, and that's as big as I'm going to get it to go. So I'm going to bring down my 4, subtract, right? 40 minus 36 is 4. Bring down my 5. Now it will go in evenly. 6 times what to get to 45? We're going to see if it will go in evenly, right? So we're going to go 45 divided by 6, or counting by 6 until we get there. It's going to go one more time, so we're going to go 7. Okay, 6 times 7 is 1 more than 36, so we're at 42. Okay, and then we're going to subtract, and I get a 3, and I'm running out of room here, so I probably should have written that a little neater, but there's the 3. I know, it's down here at the bottom. It's a 3. I can add a 0, I can bring it down, and we're going in 30, and it goes 5 times. 6 times 5 is exactly 30. So, what was the weight of each bag? Each bag weighed 1 675 pounds. Okay, so this is a multi-step problem. We have addition, we have subtraction, and we have division. Sometimes that's the case in these problems, so you've got to be prepared for that. You guys are going to go work on Modular 1, Lesson 16. This does happen to be that last lesson of the unit. Woohoo!